Hello everybody, welcome back to this week's live stream. I hope you're all doing well. We are in week 6, a little over halfway through the term. This week we're going to be talking about the endocrine system, their functions, and just some hormones that are important to us. So without further ado, let's go ahead and get started. Just as a reminder, I'll be putting in the Google form like 20 minutes in, halfway through, and then I'll make sure to put it in the chat at the end of the stream as well. If you ever need an extra copy, just feel free to put it in the chat. I'm usually good about copying and pasting it. But, okay, awesome. Let's get started. So, how do hormones regulate cell functions? In this, we're going to just be looking at hormone 1 and 2 and answering some questions associated. Hormone 1 is a protein-derived hormone. The cell responds to hormone 1 by increasing production of substance X. Hormone 2 is a cholesterol-derived hormone. The cell responds to hormone 2 by decreasing production of substance Y. So I'm just going to highlight some things in both of these in different colors. So it is a protein-derived hormone, and it increases the production of X. Hormone 2 is cholesterol-derived, and it decreases production of substance Y. 1. In medical applications, the type of hormone dictates the mode of administration. For example, oral versus injection. How would you need to administer hormone 1 to an organism deficient in this hormone? Because hormone 1 is protein-derived, as we set up here, it's likely to be digested if taken orally, meaning that it wouldn't actually work. So, protein hormones must be administered by injection. Something similar to this is, not similar, but an example of this in real life is insulin. Because insulin is a protein-derived hormone, it has to be injected as opposed to taken orally. And B, how would you need to administer hormone 2? So since we know that hormone 2 is cholesterol-derived, they're generally not digested if taken orally, and so from there they would pass from the digestive tract into the lacteal system and then move into the circulatory system. This is also an example of birth control pills. I'll put examples below. So this was insulin. But cholesterol-derived hormones you can take orally. Alrighty. Number 2. Hormones often act in antagonistic fashion. That is, one hormone will initiate a certain response while another inhibits that response. Illustrate this process using insulin and glucagon as an example of antagonistic hormones. Insulin and glucagon, a little background, regulate blood sugar concentrations, and they do so within a fairly narrow range, meaning whenever our body changes even a little bit, both of these hormones act quickly to restore that homeostatic balance within our blood sugar concentrations. So, let's say after a meal, or post meal, insulin, sorry, the pancreas, okay, so after a meal, the increases in blood sugar concentration are what stimulate the cells of the pancreas to secrete insulin. So increase, which is that arrow, insulin then triggers the cells of the liver and body to take up more glucose and store it as glycogen. Both the blood sugar level and the release of insulin drop after all this has happened. So once the insulin is released, it's triggered the cells to uptake that glucose and store it. It's now done its job, and its numbers decrease, and as well as the level of glucose in the blood decreases because we just uptook that into our cells. So then, in reverse, low blood sugar cause different cells of the pancreas to respond by releasing glucagon into the blood. Glucagon then triggers the liver to break down glycogen and release glucose into the blood. So here's how we see how they're antagonistic to each other, where they're both wanting to maintain that homeostatic level of blood sugar, but they do so in opposing ways, where insulin is what responds to high blood sugar levels, to decrease the glucose in the blood, and glucagon is a hormone that responds to low blood sugar to trigger the release of glycogen and then thus the release of glucose into the blood. So they're kind of inversely related to each other. Okay. Number 3, assume you are trying to characterize one of the hormones that are involved in the neuroendocrine regulation of milk production. You take extracts of the blood and mammary tissues of normal lactating animals and assay these extracts by injecting them into animals that have had their hypothalamus glands surgically removed. You are looking for restoration of milk production. Indicate whether each of the following findings is consistent with the hormone being steroid, a peptide, or either type. So a steroid looks like cholesterol. A steroid is just a classification of a 5-membered ring, and a peptide is derivative of something that comes from a protein. So just to clarify those two, as either a steroid or a peptide. And to recall, we remembered that peptides cannot be ingested orally. They'll be degraded into the stomach. They'll be digested. They won't be able to pass. But steroid hormones, on the other hand, like birth control, can. So, if it is found in the blood, either type actually pass through the circulatory system. So, either type is consistent to being found in the blood. B, it is found in the cytoplasm of mammary tissue cells. So, only steroid type hormones are actually able to cross the cell membrane. Proteins are these peptides are larger complexes and generally don't act favorably with the membrane enough to pass through. But cholesterol is something that's a steroid hormone that we see a lot of in our cell membranes, and so it would make sense that only steroid type hormones are able to cross and therefore be seen in the cytoplasm of those mammary tissue cells. Okay, moving on to the next page. C, it is found associated with receptors. In this case, both types, both steroid and peptide hormonal types, associate with receptors to produce a response, but the difference lies in the location of receptors. There are surface receptor cells and receptors that are within the cytoplasm. But in this case, because it's saying just associated with receptors, all hormones associate with receptors. So either type. It is found associated with protein complexes that contain a G protein. Only peptide or protein hormones associate with G protein complexes. Harkening back to what I talked to previously, how peptide hormones are normally seen on the outside of cells, not always, but normally. And one of the major examples is that G protein receptor, where that complex meets with the hormone that attaches to the receptor, and then it has an amplified response. So only peptide would be seen with G protein complexes. Or E, it is found in nuclear extracts of cells. Only steroid hormones are able to enter the cell and enter the nucleus. We talk about that passage through the membrane and how steroid hormones act favorably with the cell membrane. They can pass through, and so we would see them in nuclear extracts. We would see them in cytoplasm. We would see them anywhere within the cell, but the key is just to remember what's in the cell. Okay. Glucagon and insulin are hormones that act homeostatically to maintain glucose levels in the body. Are the following statements true or false concerning insulin and glucagon, and explain your reasoning? Excuse me, sorry. 4. True, false. Their production and release is stimulated by trophic hormones from the anterior pituitary. This is actually false. The pancreas is what monitors the level of glucose in the blood and in the interstitial fluid. So the anterior pituitary is not actually related in this case. And just to break this down further, there are two types of cells within the pancreas. There are alpha and beta cells. And so beta, this little bead, stimulate the release of insulin. So they are stimulated when blood sugar is high. And then the alpha cells release glucagon. In response to low blood sugar. And I know, I'm so sorry about my voice, guys. I'm still getting it back. But I know that the terms glucagon, glycogen, and glucose, all of that seems, to me when I was learning it, it was hard for me to decipher between the two. So just remember that glucagon is the hormone. Glucose is that simple molecule. And glucose times N, because that's just any number, N being any integer. And that is what glycogen is. So I know, I'm sure you guys are very smart, so maybe this isn't an issue for you. I just wanted to put that out there because I know I've been throwing out the terms a bunch. Okay, 5. True, false. They are examples of antagonistic hormones. This is true. So this was that example that we used. We talked about this in that first question about how when that blood sugar is high, these beta cells release insulin. When blood sugar is low, these alpha cells release glucagon. So they're antagonistic. And that they operate in antagonistic ways to maintain blood sugar levels. I remember blood sugar levels are about 90. Oh, I knew I wrote something wrong on my key. It's like, that doesn't make sense. I work at this in the hospital. Okay, yes. 90 milligrams per 100 milliliters is what the optimal blood glucose levels are at in our body. And 6, true, false. They act by stimulating storage or release of glucose from cells. And this is true. So insulin stimulates storage and glucagon stimulates release of glucose. Okay, I'm going to put the form in the chat. This is actually it today. I know this was super short. I actually didn't expect it to go this short because last week's was a little bit longer. But that's actually all the material I have. So if you have any questions, feel free to message me, let me know. If you guys message me here on Twitch, I do normally just go on this Twitch when I'm live streaming, so if I don't get back to you immediately, don't worry. I do check it when I'm on, and I'm definitely responding to your emails. But yeah, that's all I had to say. So, any questions? looks like there is not a lot of questions. Thank you guys so much for coming. Thank you. Yes, I feel fine. It's just the annoying congestion that gets left over. But thank you so much. All right, enjoy your weekend, guys. I'll talk to you very soon. Bye.